Welcome back. This is lesson 7.5 journal. We are going to evaluate algebraic expressions and formulas. I will be able to evaluate algebraic expressions when given a value for a variable. I will correctly use the order of operations. To make sure my work is correct. All right, vocabulary for this lesson. Let's recall what a variable is. A variable is a letter that we use in replacement of a number for a value that we don't yet know what it's worth. Okay, an algebraic expression is using math symbols, numbers, and variables to express a mathematical idea. And to evaluate means to give it value. So we are going to be giving a value to an expression. All right, so let's look at this example. It says, Wallace buys some bananas at the store for $3 per pound and apples at the store for $2 per pound. If B represents the pounds of, got a little typo going on here. Pounds of bananas, and A represents the pounds of apples. Those came from here. Oops. Write an expression that represents the total cost for all the fruit he could buy. So, A is going to be the pounds of apples. B is going to be the pounds of bananas. So we would take $3 and we would be multiplying that by the amount of pounds of bananas we are buying. So 3 times the bananas, but then we're adding that to the apples, so we're going to do 2 times the pounds of apples we're going to buy. So right there, that means we would have 3b, remember that's the same as 3 times b, 3b plus 2a. Okay, now let's try this other one. So we just wrote an expression. This could represent for any amount of bananas and any amount of apples. I would end up adding it together to figure out my total cost. All right, let's read this one. It costs $15 to get into the theme park and then an extra $4 for every carnival game played. If A represents the number of games played, write, and you see where that came from, expression that represents the total cost of going to the theme park and playing G games. So our variable is G. So to begin with, we have to pay $15 just to get into the theme park. So it's going to be 15. Now that doesn't go with the variable. It's $15 no matter what. But then from there, we have to add how much we're going to end up spending on the games. The games are $4 for every carnival game. So it'll be $4 times the number of games. We could also write that as 15 plus 4g. We don't have to write the times sign in there. Now you see how each of these expressions represents the situation up here. So right here it asks, what value is each algebraic expression worth? What value is each algebraic expression worth? What is this worth? 10? 500? 2,000? At the moment, this algebraic expression has no value. They have no value. All they're doing is representing what's going on. This means nothing until I know how many games I'm going to play at the theme park. This means nothing until I know how many pounds of bananas or apples I have. So what does each algebraic expression represent? Each expression represents the operations needed to show the mathematical ideas from the story. Or let's just say from life, because these are all just real life situations. So we know that we were adding. We know that we had to multiply the banana pounds by 3 and the apple pounds by 2. That's what's shown here. But right now it has no value. I can't say it's equal to 10 or it's equal to 25. That changes when we have values for our variables. So now this says evaluate the expression if A equals 4. So in other words, he bought 4 pounds of apples and B equals 2. So he bought 2 pounds of bananas. So if this is the expression, to evaluate it, I'm going to replace A with 4 and B with 2. So 3 times B, which is 2, plus 2 times the pounds of apples, 4. Now if I do the math here, 3 times 2 is 6, plus 2 times 4 is 8, and then 6 plus 8 is 14. So what does that mean? It means he spent $14 total on all the fruit. So what does it mean if A equals 4 and B equals 2? It means he buys 4 pounds of apples and 2 pounds of bananas. Now this expression has a value because I can tell you he spent exactly $14. Up here, I couldn't tell you. This works for any possible situation of buying apples and bananas. This is one specific one. The specific one where he buys 4 pounds of apples and 2 pounds of bananas. So, right here, I want to add something. It says, what does each algebraic expression represent? It represents for any value. So, that's important to note. For any value. All right, let's do this one. It says evaluate this expression. So we're back to the carnival games. If G equals 5. So we're going to put 15 plus 4 times the number of games, which is 5. Following the order of operations, 4 times 5 is 20. And then 15 plus 20 is 35. What does that mean? It means if you go and play 5 games, it's going to cost you a total of $35 for the theme park. So, it means you play 5 carnival games. So, you spend a total of $35. Now it has a value. Now this could change. I could put 10 there. And that would mean I played 10 games, or 5, or 21, whatever it might be. This has no value. This just represents any value. Down here, this one's a specific one. For exactly 5 games, it's going to cost me a total of $35. All right. Now this one's kind of cool. A scientist named Amos Dolbear discovered that you could use cricket chirps to approximate the temperature in degrees Fahrenheit if you followed the following expression. 37 plus n divided by 4, with n representing the number of cricket chirps heard in 1 minute. So find the temperature each time using the expression above. So at 7 a.m., in 1 minute, we heard 48 chirps. So we're going to take this expression. Now remember, this has no value. This is just a mathematical idea or a rule that he found that cricket chirps follow. So until I put in 48 for the n, I'm not going to have a value. So let's replace n with 48. All right, so order of operations, 48 divided by 4 is 12. And now 37 plus 12, it's easier for me if I stack those. 2 plus 7 is 9, 3 plus 1 is 4. So at 7 a.m., it was 49 degrees Fahrenheit outside. Okay, let's try this one. Now we have 72 chirps in 1 minute. So same expression, new value. Okay, 72 divided by 4 is 18. Then I add that to 37. So 37 plus 18. 7 plus 8 is 15. Regroup 1. 1 plus 3 plus 1 is 5. So at 10 a.m., it is 55 degrees Fahrenheit. See how my values are different now? I'm using the same expression, but that's because I'm plugging in a new value for my variable. Okay, at 3 p.m. we have 120 chirps. So 37 plus 120, replacing n, remember, divide by 4. 120 divided by 4 gives me 30. Add that to 37. 37 plus 30 gives me 6. So it was 67 degrees Fahrenheit at 3 p.m. All right, at 9 p.m. we heard 84 chirps in 1 minute. So we're going to replace the value of n with 84. 84 divided by 4 gives me 21. Add that to 37. 1 plus 7 is 8. 3 plus 2 is 5. So at 9 p.m. it's 58 degrees Fahrenheit. Now see how I got 4 different values for this expression, but that's because I ended up with 4 different values plugged in for my variable. So the expression is for any amount. We evaluate when we have a specific amount. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.